Hey, how's it going, guys? In this video, I'm going to go through this Leetcode 583 delete operation for two strings. We are given two strings, word1 and word2. We need to return the minimum number of steps required to make word1 and word2 to be the same. In one step, you can delete exactly one character in either string. The first word we are given is C. Another one is it. So the number of steps that we have to take is 2. Basically, we have to delete the S from the C and the T from the it. And then we have the EA from both of the words. So that's example number 1. Second example, Leetcode and Eatcode. So what we need to do is to delete LEE. So that's 2 characters for the first word, and also DE, also from the first word. So this problem doesn't seem too difficult, right? So we can just count the number of occurrences for each character on the dictionary or an array, and then compare them, right? And actually, this approach does not work because the order matters in this example. So that's why we need another approach to tackle this problem. Let's take a look at the approach written here. So we need this is actually a dynamic programming approach. So we need a DP grid, which is for keep track of the number of steps at each stage. So for example, as you can see, I lay it all out for all the characters in the word, right? C in a column and it in a row. And each column represents a character in that word, right? Okay. And also we have the default of an empty string, right? So empty string, character of E, A, and T, empty string C, E, and A. So each of the numbers in here represent the number of steps we have to take to make the two words to be the same. Okay, so the first row and the first column, they are the default. That's why I put the asterisk in here. So for example, if we have if the two words are two empty string, so there's nothing we need to do, right? So the number of steps will still be 0. And if one word has one character of E and another word has an empty string, so we just have to delete that character. So the number of steps will be 1. And if the word that we are given is EA, right, and another word is empty string still, so the number of steps will be 2. So same idea for the third one, okay? So that's the default baseline for the first row. First column is kind of the same idea, right? So we have an empty string for the word 1, right? So for example, if we have one character on the word 2, so what we need to do is to delete that character. So number of steps will be 1. Same for other rows for the first column. And then now, which is more interesting, is to fill out the rest of the columns and rows. Okay, so at this stage, right? For example, this is the first one to fill out this table is, for example, word 1 has one character, which is E. Word 2 has also one character, which is S. So what we need to do is delete both of these 2 characters. So the number of steps will be 2. And in this stage, number of steps will be 3. We have to delete both of these 2 characters and plus the 1 that on the other word. Same for the other column for the second row. And when we move this stage, things become a little bit more interesting, right? Because this character is the same as this one. So what we need to do is just remove the S from the C, right? Basically, for example, at this stage, we have a string of SE, and for the word 1, we have only one character, which is E. So the only thing we have to delete is the S. Okay, so the number of steps we have to take is just 1. Okay, so as you can see, when you go through the rest of the table, and that's the answer that we're looking for at the bottom right corner. So that's exactly that answer over here. And the formula to fill out this table is this. So if the character that we're looking at are the same for both of the words, and it will be 1. Oh, sorry, it will be different. So if the character is different, the entry will be 1 plus the minimum of the last column but same row, or the last row but the same column. So basically, for example, in this case, okay, and these two character is not the same, so it's gonna be 1 plus the minimum of this guy and this guy. So the minimum, they are the same in this case, so it's 1 plus 1, which is 2. Okay, let me find another example that is different. Okay, so okay, this example is different. Okay, E and A. So first, they are the different character, so that's why we fall into this criteria. And then the two adjacent number, they're different. So one number is 1, another number is 3. Take the minimum of the two, which is 1 plus 1 on it, so it's 2. So that's how we come up with that entry. And on the other hand, if the two characters are the same, we just look at the diagonal. So for example, this character, right? So it's E for one word and also E for another word. So we just look to the diagonal, which is this guy over here. And it kind of makes sense, right? So let's say for this guy over here, C and the A, the character of A, and EA and the character of A as well. So they are the same. They kind of cancel out each other, right? So what we need to do, just look at the prior step, right? And SE and E, right? So that makes sense. And for this one, in the case where if they are different, and why is that formula is that, for example, consider the one that we talked about, right? So if the two characters are not the same, and there are two ways to get to this stage, right? Either we go from the top or go from the left, and we can find the shortest path. That's why we take the minimum. And now the character is not the same. I have to add 1 to it. So that's why this formula works. Okay, at this point, feel free to pause the video. I'm gonna implement this algorithm in the code, and yeah, feel free to try it yourself. So this is the entire implementation. As you can see, the code isn't that hard. Let's walk through it together. And first, we have N1 and N2. Basically, they are the length of the word 1 and word 2. And we also have the DP array, which is a grid. Okay, and so we initialize as a grid as all the zeros everywhere, right? So basically, it's a 0. Repeat N1 plus 1 times, and append it to the DP for N2 plus 1 time. And the reason why we need the plus 1 is because the empty string at the beginning, that's our default case. Okay, and now we need to fill out the first row and also the first column. So basically, what we can do is to so basically these 4 lines in here, what they do is to fill out the first the very first. Let me zoom in a little bit. The very first row, 0, 1, 2, 3. And also the very first column, also 0, 1, 2, 3, because in this case they are the same length of the two words. Okay, and that's what these 4 lines do. And then now we can fill out the rest of the grid, and then we will start from here, and then from here, the second row and the third row, right? So the inner table. So the outer one we have already done by the 4 lines, and here, and here, and here. So that's exactly that, right? We look through all the rows, and then the columns. We index it starting from the second index, which is 1, and all the way to the end. And now we do the comparison of the character, right? Because we have the 2 cases that we talked about before, right? The same character or the character is not the same. And then if they are the same, we look at the diagonal.
If not the same, we put 1 to it for the different character that we're looking at. Also look at the minimum of the path that we can get to that stage. And at the end, what we need to return is the last index of the grid. So basically look at the last row and last column. And Python allows us to do that very convenient, right? So basically look at this guy over here at the corner. Okay. Just put the index of -1, that's the last row, index of -1, and last column. Let's run that, and it works. And also pretty efficient. For time complexity, it's going to be big O m times n. So m being the length of the word 1, n being the length of the word 2. Because we have this double for loops in here. So same for space complexity, and because we need a dynamic programming array to keep track of the steps required to get to each of the stages. So this is the end of the solution. I hope this is helpful. If it is, please like and subscribe. And remember, don't trust this, try yourself. Thank you for watching.